was going to say histograms were goodness. It just was going to take all the way to 12 to do it. But at least he's doing. Just a caveat, I'm going to say this only because the head of the optimizer development group will pretty much shoot me if I don't. We don't encourage you to manually set your histograms in such a manner. We encourage you to create them for you and stuff. Don't be doing any of that fancy stuff that he just showed you. Okay. We would prefer that you were open and honest with your optimizer and told it all of your woes and your complaints directly to the optimizer, right? Because unfortunately the optimizer does make some assumptions, and as you know, if you assume things, you can very quickly make an ass out of you and me, right? So what does the optimizer assume? What are these kind of things we're talking about? I'm talking about stuff like, if you add additional where clause predicates to a query, right? We're assuming each one of those additional where clause predicates is going to reduce the number of rows being returned from that table. And I'll show you an example of that in just a minute. We also assume that if you're doing a group by, each additional column you add to that group by will reduce the number of rows that the group by is going to return. We also think that if you apply, or we know in fact, if you apply a function to certain column data types, that we have no idea the number of distinct values now in that column after the function has been applied. We'll talk about that one in a little bit. So it is best, as I said, to be open and honest with your optimizer in order for it to do the smart thing. What do I mean by this? Well, here's a pretty simple example. I have a table that's called vehicles. It's got information about cars. And the query is pretty straightforward. So let's start from the vehicles table where the model is equal to a 530 Xi and the color is red. Now, remember I told you the optimizer assumes each additional where clause predicate will reduce the number of rows being returned. The reason I say that is that that's the formula that the optimizer is going to use to calculate the cardinality estimate, or the estimated number of rows being returned. How does it do it? It says, I take the total number of rows in the table, multiply it by 1 over the number of distinct values of column 1, well, column 1 is model in this case, times 1 over the number of distinct values of column 2, which is red. Do the math, and you get 1 row being estimated, and we got 1 row returned. Life is good, right? This assumption that the optimizer makes typically is a good thing. What if I change that second where clause predicate to be model, make? So now I'm looking at model and make. Now we all know that BMW is the only manufacturer or maker that has a model 530 Xi. How do we know? Most of you are boys, no offense ladies, and my husband told me, so that's how we know. We know that. The optimizer doesn't know it because we haven't told the optimizer this piece of information. The optimizer assumes that an additional predicate in the where clause is going to reduce the number of rows. It's going to use exactly the same formula it did for the previous query. And when we do the math for all of that, it comes out again with an estimate of 1 row. How many rows did we actually get? 3 rows. How do I tell Oracle that some of the columns in my table have a real-world relationship or have correlation? I tell it with the use of extended statistics. DBMS stats, extended statistics. You all told me, hopefully you didn't lie, that you're on 11G. So if you're on 11G, you've got access to extended statistics. Extended statistics, you create them once. So in this case, I'm saying DBMS stats create extended statistics on the vehicle table, and I want you to create statistics or data statistics on the model and the make columns as a group. That's what putting them in the brackets there together tells the optimizer. It tells the optimizer, I want you to gather stats of these two together. We then go ahead and just gather stats the way you're supposed to, schema name, table name, nothing else. And what it's going to show you, if you look in user tab column statistics, is this weird system-generated column is now there, right? So system-generated column name, and what that is basically a set of statistics gathered on those 2 columns as a group. When we see those 2 columns being used together in a query, we don't use the individual column statistics anymore. We use a brand new formula that looks at those extended stats instead. And we can get everything from the number of distinct values for that column group and even a histogram for that column group if it's necessary. All right? So if we look now at the optimizer's estimate, we're using that new formula, as I said. We're getting an estimated number of rows, 3 rows, actual number of rows, 3 rows. So extended statistics are your friend. Now, if you're like lot of the DBAs that I talk to, you're looking at more than just one database. You might even be responsible for thousands of databases. How are you supposed to know if you've got these correlated query or columns in your data set? Well, if you don't know, if you're not very familiar, and the developers in your organization who write the queries against your data model don't talk to you, God forbid that the developers and the DBAs would ever talk, but if they don't talk to you, one of the things you can do is you can use DBMS stats C to call usage. What that allows you to do is either give us a SQL tuning set and have us determine what column groups you need, or you can run it live on your system and have Oracle monitor the SQL that's coming through on the system, and based on that, decide what column groups or recommend what column groups are needed for that workload. Right? So DBMS stats C column usage. First two parameters there is the owner of the SQL tuning set and the name of the SQL tuning set. If you leave them null, as I have in this example, that says monitor the live system. How long will it monitor for? That's the third parameter. The third parameter there is the elapsed time. In this case, I gave it 300 seconds or 5 minutes. So just monitor the system for the next 5 minutes. Let me know what column groups you would recommend based on the SQL that is going on in this system. Now, one of the beauties of this is that because explain plan does a parse, and assuming your workload does not have binds, you can simply explain the queries and have us pick up the column groups. Right? So you don't have to execute them, you can simply explain. Got something better than that?
Well, the reason why Maria wanted me up here was so that I wouldn't be sitting down there. But I haven't had anything to complain about yet. Ooh. Okay, telling the optimizer everything. As much of the truth as you possibly can. I'll pick that one up and run with it. Bad default values. How to lie and confuse the optimizer. Let me just demonstrate how badly things can go wrong. I'm going to create a table here, a little bit of arithmetic. Everyone ready?